recording this because teachers are going to look at this lesson and they're going to see your discussion. You guys are going to lead the discussion. Now, I know we talked about balloons the other day. Did we talk about one of these? We did. Okay. So I have one of these, right? Perfect. All right. So we'll talk about the use of one of these. And then I do have balloons, but I also have one of these. What's the volume that one of these holds? How much can fit in here? 2 liters, yeah. Sherry, would you flip that fan off? Hayden, would you flip that fan off? Okay, so right now, the volume of air in here is what? We need to come up with a plan to prove that air has mass. Ideas? Yes, ma'am? Weigh it with the cap and weigh it without. Okay, so at this point, I'm going to have you guys come up here. It's going to be a little tricky because there's a lot of us, but I need you like around here. And then Ella, I'm going to have you position like maybe here. So you two need to be like at this angle because I need you to be able to see this. So, okay, I can measure, and I'm not really measuring the weight. I'm not really doing the weight. What am I doing with this? I'm not weighing it. What am I doing? I'm measuring something though. I'm measuring the mass. Okay? And mass is okay, so how much matter is in here? Not only do I have the air contained in here, but I got the bottle, right? And why would I weigh it with the cap on and without the cap on?
Because with the cap, you're trapping the air in, and if the cap's not on, then it's just a bottle.
But I'm removing mass.
Wouldn't you have to weigh the cap first, though? Because the cap would add to the weight if it's on, but if you're taking it off, you can see that. It's going to take off the weight so you can compare it correctly.
Thoughts? Sir?
I don't think this really works because even if you remove the cap, air's still going to fill it up. Like, there just won't leave because the cap comes off.
So really, what I'm measuring is the difference between the cap on and cap off, but I'm not changing the air. Thoughts? Let me introduce another tool to you. BizKeeper. I don't know. Oh.
Oh, it was more into it.
Thoughts? Kennedy, what do you think?
I want to know what the bottles are getting bigger. Like it. Stuff.
Okay.
So maybe you could fill it with air with that, and then vacuum out all the air to figure out how much it weighs without. Or maybe it's the amount of pumps that you put into it is different.
The amount of pumps you put into it.
Jackson talked to me about that. She said maybe it's the amount of pumps you put in.
Like how much air you're putting into it. That would like change like how much it weighs, probably.
I'm gonna convert you over to mass, right? It'll change the mass of it because we're increasing. Brooke, what are we increasing?
Air. We're increasing. We're adding more air into the bottle.
Okay. So, what do we expect to happen? What do we think we'll see? It's gonna get heavier? Not heavier, because remember that's weight. This kind of takes weight out of the picture because it balances it against grams. So it's actually measuring just the mass, not the weight. How much stuff is in it in grams. So you would expect the grams to what, Trista? You would expect the mass to do what? Remember if-then statements? If we then what do you think the mass will do? Phone a friend, help her out. If we
There'll be more mass in it.
There'll be more mass in it. So we can prove that air has mass. Are you ready? I need a volunteer to write on the board. Go for it. You're going to pick a nice black pen. You're going to make a chart that fills that white space. All right. May I? Oh, yeah. Pass that around. Okay. What are we labeling the top of the chart with? What sorts of things are we going to record in our data?
Mass.
Okay, so we're going to record mass. I don't know. We've got 3 columns. You got 3 columns going on. How are we going to set this up? Sage, if you held it, hold it. Now I want you, everybody listen. Release it. Isn't that lovely? Okay, plop it up here. All right, so what are we doing? What are we changing? So we're setting up an experiment, right? What are we changing? What are we doing to the bottle? The amount of air that's in the bottle, and we're going to measure that in terms of what? We don't really have a way to measure the volume, but we can tell what? How many pumps? So let's do pumps with a hashtag meaning numbers. Okay, and as we add more pumps, what are we going to do each time? Measure it, and in terms of what? What are units?
Grams.
So we're going to do grams. So that does mass, and in parentheses, you're going to put G. Little g for grams. Great. And in the last column, well, we'll get to that. So how many pumps should we start with?
3.
How about first? None. So 0. 0 pumps. Okay. You used one of these before? You have. Fantastic. All right. So you will notice, and you're going to want to come this way. Scoot this way, guys. We got a little bit of space here. You move this way. She'll be able to see. We'll keep her informed. But kind of circle in here. Okay? Because I want you, yeah, Jamie, you're going to and you're slightly shorter than him, so scoot in front of him. Come forward. Yep, right there. Good. All right. So you'll notice here, this one goes by 10. This one goes by 100. This one goes by ones and decimals, right? Y'all see that? Okay. Estimate, what should I start with? This needs to get to 0. It needs to balance. Start by ones. Is that about 1? Did it move? No. Okay, what should I go by? Tens. Estimate? 20. 10, 20. Notice I'm doing these little notches. Didn't even budge. Hundreds. Too much. So you said 50, 10, 20, 30, 40. Is this 50?
Yeah.
Nothing. 70? 70.
65.
Okay, here's 60. All right. I'm going to borrow this. Don't let me steal it. Okay, so notching this over. What's it at?
4.5.
65. Okay. Is it there?
No.
69. Too much.
Wait.
68 points. Good? Are we good? Okay, for 0 pumps, we have 68.5. Beautiful. Okay. How many pumps? Not yet. How many pumps?
5,
10,
20, 25,
50. Let's do 50. Really fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Stop. Were you counting?
Yeah.
Oh, good. Was it 50 for you? Keep going. Perfect. Okay. All right, Zach, since you're sitting here, just put one more in. You do the honors?
One more.
Nope. Put it on there. So we did 50 pumps. You want that to be exactly in the middle. Is it?
No, it's almost.
It's almost. All right, so that means we need to move this ever so slightly. What direction are we moving? Right. Let it balance out. What now?
It's like
Just above it. All right. Got it. Who's got it?
there.
All right, what's the reading?
It's 68.7.
68.7. Fast. You count out loud. To 50. We're going to add another 50 pumps. Here we go. Okay, plop it on there, Macy. Zach, can you scoot that way to allow Macy to kind of do some adjustments? All right, help a girl out. All right, what do we got? 69.0. All right, 69.0. Check out our
It's 68.
68.9. Check out our chart. Thoughts? Is there other information you can start adding? Brooke?
For every one pump, it's so much per weight, so we could figure that out.
I'm thinking of a third column. What would you throw in that third column? Are you starting to notice any patterns? What's that? Maybe.
It's going up by 0.2.
What do you mean it's going up? Never use it.
The mass is going up from 68.5 to 68.7 to 68.9, so the mass is going up by 0.2.
What is that pattern? What could be a third column? Changed weight. The changed mass. Do you remember the symbol for change? Delta. So we're going to do a delta G. Delta is our symbol for change. It is the difference in the, yep, very good. Awesome. 50 more pumps. Lucas, I think you were talking smack about how slow he was going. Yeah? Okay. You count out loud. Don't make eye contact with the teacher, Jimmy. There you go. Scoot that way. Are you ready? Bold strike. Did he do it just perfectly?
No.
Oh, give it a second. It's still wiggling. Too far?
More precise.
What do you think?
Like,
More right. No.
That's good.
Boom.
Wow.
Disagree. I think you just need to nudge it this way, smidge. Smidge.
Is that a smudge?
I don't know. No, that was a smidge. All right, we're going to let it stop moving. There you go. But I need the reading from you, Jamie. What's the reading?
I can't read.
Yeah, come closer.
60.9. Oh, wait. I don't know.
Okay, so this is 69 point.
Yeah, okay.
Point 2 and a half? Okay, 69.2 and a half.
how do you use it?
25. There you go. Okay, so that's 150 pumps. One more? One more round? Do you want to? Okay, 50. Fast. You're counting right. Brianna. Delicate, come over here. Predictions. What do you think the next number is going to be? She's going to adjust. You guys predict. What do you think?
It's spot on.
69.5?
Would it be 5 or 5.5?
Okay, beautiful. Are we ready to fill out delta G? The change in mass, the change in grams? Yeah? Okay, go for it. So the first one you can just put a dashed line because there was no change. That was our first. The second one is the difference from 68.7 to 68.5. What is that? Okay, write it down. Math. Is that right? What's 69.25 minus 68.90?
0.45.
You just want to longhand it? I'm not going to give you an answer. You guys got to figure it out. Come on.
Like say 0.35.
Sure? Make sure? Absolutely positive? You're not positive? Or that's not right? You're positive that's not right? I think you're right. All right, and then the next one. Math.
0.25.
Okay, so who wants to start us off on conclusions? What are we thinking? What is happening here?
Every 50 pumps, the mass is increasing about 0.2 grams.
Throw someone under the bus or pick them up. Be engaged in this conversation.
Let's see, what would be 0.50 increase 35 plus 50 equals 50?
No. It's a
You
change
go from
between.
0.25 to 0.5.
No.
0.50 is what it is.
No,
35.
look, the change between 69.
No, leave it at 35.
No,
But if you add 35 to 25.
yeah, but if you put a 0
It's
after
point-
the 5, it's 25 to 50, which is 25.
I know, but if you add 35 and 45.
But we don't need to because that's the change. We need to add 25 to 25. You need to add this way because we subtracted this way. Good thinking. All right, so Kayla said the mass is increasing every 50 pumps. And then she threw you under the bus, Kennedy, to add to her statement. Other thoughts?
The mass is about
In general, is it a big change between them? No, it's not. Okay, so it's very small changes, isn't it? Yeah. Okay, throw someone under the bus. Okay. Other thoughts on this, Macy? What do you observe? What do you see? What can you add to Kennedy's thought? Y'all think about your thoughts, right? Because you could be next. What do you think? Why don't you ask that question in the purple to someone? Kayla has already answered. And ask the question.
How does this experiment prove Jenna?
Because of the change from 0 to 200 pumps. If the air didn't have mass, it wouldn't change no matter how many times we pumped.
Ooh. Okay. By throwing someone under the bus, you just pick someone who looks like they're not paying attention or hasn't spoken yet, and ask them their thoughts on what you said. You may need to repeat yourself.
I agree because, like she said, it wouldn't be able to change it. Like, if it didn't have mass, it wouldn't be changed.
Okay. I'd like y'all to go back to the next available page in your lab binder. Record that chart in its entirety. Record that question, and then answer it in your own words. What do you got? Yeah, that would be. So you might have room on page 5. You might have room on page 8. And you can go ahead and stop. Thank you so much. Mrs. Rudd.